The next product that we're going to go through is the SF1015 fluid meter. And again, as you'll notice with all of our products that we discussed today, the main focus that we really wanted to go with was the ease of operation, reduced downtime and maintenance costs associated with repairing our products. And then certainly you'll really notice that with this product. And again, one thing that we wanted to do, as you saw with our other products, is we wanted to be unique. You know, basically what you find is we had the big customers that of course had their patents, and as soon as their patents run off, everybody jumped on the bandwagon and wanted to make a copy of it to make some money off of something that somebody else designed. And of course, we didn't want to get into that game. We really wanted to see the problems that people were seeing in the field. We wanted to come up with a solution for them. And of course, probably one of the larger applications that I've seen where it's a known problem is in the turbine meter in fluids. Of course, if it's clean water, no problem. You're not going to have that many issues. But as soon as you introduce any kind of solids or erosive product into that liquid, now we've got a real problem. Or if you've got gas breakout, it's extremely detrimental to a conventional turbine. So basically, just to go over, most turbines, as everybody's familiar with, it's like the true turbine. The rotor actually spins intrusively in the line. It covers the full path of that fluid. The water basically hits the blades on a turbine and it causes it to spin. But of course, because you've got these flat blades that are being hit by potential projectiles, solids, sand, and stuff like that, of course, because you've got these flat blades, as soon as they hit them over a period of time, sometimes within a matter of hours, you can actually tear those blades apart and erode it right away. So what we did is that's where we came up with our product. Again, we wanted to keep it extremely user-friendly. So when you look at our competitions, whenever it comes time to repair it, you physically have to pull that turbine out of the line. And then there's a bunch of steps that you need to go through to get the guts out of it and replace it. So of course, when you pull that turbine out of the line, you have a mess to contend with. You've got all that fluid that's in that line that you now need to contain, clean up. And what we wanted to do is, like I said, we wanted to make ours as simple as possible. So this is our turbine meter. Again, it's bi-directional. We don't care which way it goes in line. And what we wanted to do is we wanted to make it extremely user-friendly to repair. So basically, you don't even have to take the body out of the line. So it's as easy as bleed your line pressure down. All you need is an Allen wrench and an Allen key, and you can take out your top plug. All the guts come straight out the top. This turbine, the body stays in line, and you can get all your parts replaced. Get all your parts. Again, all you need is an Allen key. At this point, you can repair it within a matter of minutes, drop it back in line, it's self-aligning itself, so it drops itself back in line, and like I said, within a matter of minutes, you're back up and running again. The other thing that we wanted to do is we wanted to eliminate the wearing factor that you see with a conventional turbine meter. So what we did with ours is as you can see with this blade in here, we actually spin in the same direction and velocity as what the fluid does, and as a result, because we're spinning in that same direction and velocity as what the fluid does, even if you have solids that come through there and it may make contact with the rotor, it'll just make contact with the rotor and carry on as if nothing happened. So we've gone in applications where, again, you'll last a day, a week, and you'll tear that turbine out, and we'll last years. I like to joke with guys that if there's a problem with my turbine, it's that they don't wear out quick enough. They'll last forever. Because of the design of them and what we've done with it and the technology that we use, it really does eliminate that wearing, pretty much completely eliminate that wearing factor with our turbine. For us, our biggest stumbling block was because we're taking the turbine and we're sticking it in the path of fluid, we're taking a good portion of that out of the path of the fluid. Our accuracies were our biggest stumbling block initially. So as we progressed, we found better products, stronger products, and basically what we do is we have a turbine, or the paddle, as we call it. Instead of a turbine, it's a paddle. We'll press in a carbide bushing, and then we use a carbide shaft. So the initial material that we had, it wasn't as hard as the stuff that we have now, so we had to have more of it, and of course it created more friction. And as we found better products, what it did is it allowed us to dish out and reduce some of the the contact points within on the carbide parts, and now we've been able to go from our initial, where we were about plus or minus 5%, we can get down to plus or minus 1%, which is as good as our competition. So we're getting as good a turn down, we're getting the same kind of accuracy as a competition, but when we compare, you can't even, like, it's not even a comparable factor when we look at the life of our turbine over the life of the competition. Like I said, we'll go in there, and we actually have a gentleman that works with us that used to work in that industry, and that's what he said. He said we would pretty much give the bodies away so that we knew that we were going to get the repeat business of that wearing internals, and they actually sell the internals for almost as much as the body as a complete unit, because they know that they'll make up their money. So the first time you go to repair this turbine, it's made all your money back in one go. The other thing that we did is we really wanted to make sure that our turbine was retrofittable. When we initially built our turbines, we didn't make our own totalizers, so we really wanted to make sure that it was interchangeable. We didn't want to have the customer, because it would have been a real stumbling block if they, we went up to them and said, you got to turn out the turbine and you need to buy the monitor as well. So what we did is we developed our product so that you could actually take their pickup coil, you could take their totalizer monitor, mount it on top of ours, punch in our K factor, and you could have it up and running within a matter of minutes. Since then, now what we've done is we actually manufacture our own totalizer, and again, it's just a very simple, user-friendly type monitor. It's intrinsic safe, battery powered, and it gives pretty much all the functionality that all the competition that we have now, and of course it's a very competitive product that we sell into the market as well.